right, we get to start chapter 2 today. All right, first of all, this is an easy concept to start with. You'll love it. Domain and range. X values are domain, Y values are your range. You can get ordered pairs and figure out domain and range. You have a table where the left side is domain, the right side is range. You have a mapping diagram. The left side is domain, right side is range. And of course you have a graph where you have to have that X and Y value. Domain is your X and range is your Y. All right, let's take a look, and these are called relations, by the way. A relation is a mapping or pairing of input values with output values, and that's what all of these represent. X is the input, called domain. The output is called the range, and they're called a relation. Okay, so our inputs are domains, -2, -1, 1, 2, 3. There you go. So that's considered your domain. Input, domain, same thing. And our range, -3, 1, 3, -2, 1, all the Y values, also known as range. You can also show it on a graph. You can put the same information that they had in ordered pairs on the last slide over here. So you put them all on the graph. We did that a lot in geometry. Now you also can do a map with all those ordered pairs. Here's your input, output. That was one ordered pair. -1, 1 was another ordered pair. We had 2, -2, another ordered pair. And we had 3, 1 as another ordered pair. All right, so basically we can graph, we can map. Now, a function is a particular relation for which each input you get exactly one output. So every X value can only have one Y value. That's a function. If the X value has more than one Y value, it's a two-timer and not functional. Let's take a look. This is an X, it has one output. This is an X, has one output. This is an X, has one output. This is an X, has one output. So every single one of the X's only has one output. So this, to tell whether or not it's a function, I just looked at all that. So yep, it's a function. Because the relation is a function because each input is mapped onto exactly one output. All right. Let's take a look at this one. One output. Uh-oh, two outputs. This one is not going to be a function. All right, so as soon as you come around and you see that the X has more than one output, that's not a function. That's how you tell. Now, I would like you to take a look at these two questions and try them out on your paper in your notes. Pause your video. Welcome back. Let's see how you did. Did you name the domain and range? Domain should have been -4, -2, 0, and 1. Range, Y coordinates, 3, 1, -2, -4. All right, here's another one for you to try out. I would like you to take those same coordinates now, and let's go ahead and use a table. So create a table, an X column and a Y column. And then also map it. Put a map. Put an arrow between every X and every Y that actually is related to each other. Okay, pause your video, give it a try. Welcome back. Did you write them in numerical order on the X's, like -4, -2, 0, 1, -2? Okay, now you'll have all these coordinates, but you're supposed to write them in numerical order. So you've got -4, -2, 0, 1. This is how we would write them as a map. On the right side, you go ahead and list the Y values in descending or in ascending order, -4, -2, 1, and 3. Now draw your relations. This one is -4, it's related to 3. So you put -4, arrow to 3. And then you have your -2, 1. So draw an arrow between -2 and 1. And then you have a 0 and 3 are related. So 0, arrow to 3. 1, -2, so 1 to -2. And then the -2 goes to -4. So go back up to your -2 and draw a line to -4. Notice that we just had to do, the -2 has two outputs. That is not a function. All right. Now, here is an X and Y table written horizontally. Go ahead and decide whether or not this is a relation. oh, I'm sorry, if this relation is actually a function. So pause your video, see if you can decide. Welcome back. Let's see what we have. Yes, for every input, there's exactly one output. -2 goes to -4, -1 goes to -4. Yeah, I know we have a bunch of the y's being used over and over again, but the rule is for every input, one output, one output, one output. Like I could draw arrows in here, okay? I could draw the little arrow. Let's see. I think that's my arrow key. These. Okay? All right, so that's all that matters. Every input gets one output. All right, now we have what's called the vertical line test. This is the same type of idea. We're just trying to decide if this is a function. As you go along the x-axis, notice there's only one point up above or below in some circumstances. And you try to put a line, and it only touches in one point. If I draw a line here, ooh, it will only touch the function in one point. Draw a line here. It only touches the blue function in one point. Now, on this diagram, you have this blue representation of your inputs and outputs. Look what happens. The red line hits here and here. It hits twice. That's not a function. All right, so they give us this word problem. First graph below plots average points per game versus age at the end of the 2003-2004 NBA regular season for the 8 members of the Minnesota Timberwolves for the highest averages. The second graph represents plots averaging points per game versus age for one team member, Kevin Garnett, over his first 9 seasons. Are the relations shown by the graph's functions? Explain. So let's take a look. Timberwolves. Here's all your little dots. Here's all your inputs and outputs. And notice here, as you get to 28, there are two, because this is the x-axis, this is your domain. For this domain, 28, you get 1, 2 outputs. Uh-oh, that's not a function. Now, as far as Kevin Garnett goes, here's your x values. So I go along and I see only 1, 1, 1, 1. Oh, it's only hitting 1. And if I do my vertical line test, sorry, vertical. I'm trying to do vertical. Sometimes my computer doesn't want to work alongside me. Okay, so the 2 that I just drew was pretty much vertical. But when I try to do a vertical line test here, it hits twice. So that's a no-go. Not functional, functional. All right. Now, just so we can recall, this is when you have 2 variables. You have y and x listed in your equation. This is called function notation. This doesn't mean multiply. This means the function of x. That's all it indicates, okay? Now, this is considered in a 2-variable equation, x, y, 2 variables. The inputs will always be the x, and they'll be called the independent variable. The output is always going to be your y, and that's the dependent, because it's dependent on whatever x value you put in. If I put a 2 in here, I'll get 6 minus 5 is 1, so I'll get a 1. If I put a 3 in for x, I get 9 minus 5, which is a 4, so my y would be 4. So notice how my y value is always dependent on whatever I put in for x. So this is my input, this is my output. This is your independent variable, this is your dependent variable. All right, when it comes to graphing equations in 2 variables, first of all, construct a table of your values. Then plot all your points and connect the dots either with a line or a curve. Let's take a look at what that is. All right, let me see if I skipped anything. Nope, I didn't. Okay. Okay, you have y equals -2x minus 1, and you plug in your x's and your y's. So when I plug in my x's and my y's, I get these I have a -2, 3, I got -1, 1, 0, -1, 1, -3, and 2, -5. And how did I get that? Plug in a -2 here. -2 times -2 is 4. 4 minus 1 is 3. So that's how you get to 3. So you take all these little x values and plug them in. How do I decide which numbers to plug in? I usually go with low numbers that are close to 0 on the negative side and on the positive side. All right. Now, when you go to graph it, you'll notice it creates a nice line. Is this a function? Sure is, because it passes the vertical line test, and we can also look at the table. For every input, there was only 1 output. Okay. Here we go. Tell whether the function is linear. Then evaluate the function for x equals -4. take a look at this. You notice how this has an exponent of 2? If you recall from Algebra 1, anytime you have an exponent of 2 in your equation and there's nothing higher as far as the exponent, this is going to make a parabola. Now, if you recall what a parabola looks like, let me just draw one. It kind of looks like a horseshoe. Kind of like that. But sometimes they're sideways. Okay? So, anytime it has a little square, it's going to turn out to look like that. So let's take a look. We're going to go ahead and plug in some numbers. Okay, like a -4. And we get a -1 out. Okay, so it's not going to be linear. Now, oops. So that one we know is not going to be linear because it has a square, and also when we plug it in, you'll notice. Okay. Over here we have g of x equals 5x plus 8. You notice it has the exponent of 1. Anytime it only has the highest exponent is a 1 for the variable, it's going to be a line. Remember y equals mx plus b? All right. So let's take a look. We go ahead and plug in the -4 that they wanted us to do, and we get a -12. So the function of g is linear because it has the format of y, or g of x equals mx plus b. Okay? All right. So graph this equation, plug in an x, and then get out your y. Now, if you recall, you can also just take the -2 as your y-intercept and the 3 as your slope, your choice. But when you go to graph it, it looks like this. All right. All right, we're almost done. Let's take a look. I would like you guys to try these two on your own. Pause your video. All right, we should have, see how this is raised to the 3rd power? I know if it's raised to the 3rd power, it's actually going to make the graph that usually looks something like here, like that. Okay? It's not going to make a line. Is it functional? It's not a line. It tells whether, I'm sorry, I read the directions wrong. Tell whether the function is a linear. It's not linear. It's raised to the 3rd power. This one's raised to the 1st power, so we know it's linear. And then it wants us to plug in the -2. So plug in your -2, and once you plug in that -2, you will get x equals -2. And function of x will equal 0, because you will get a 0 once you plug in -2 in. All right. That's it for today. See you tomorrow.